Okay, let's just dive right in. If you're in the tech world, there's that one question. The one that can send a shiver down the spine of even a seasoned developer prepping for an interview. And that question is, design a URL shortener. It sounds so simple, right? But it's not. It quickly explodes into this massive system design challenge. So today, we're going to break it all down, piece by piece. And this right here, this is the panic that so many of us have felt. What if they ask me that tomorrow? I'm just going to blank out. So let's meet Arjun. He's a developer, and he is staring right down the barrel of this exact question. He's totally convinced he's going to freeze up. And you know what? That's a super relatable fear, and it's the perfect place for us to start. So his friend Maya, who's this really sharp mentor, she just cuts right through all that anxiety with one brilliant question. Instead of asking him to, boil the entire ocean, she asks him this: how would you make a short link for just one person? And that right there is our first big lesson. When a problem feels impossibly huge, you've got to shrink it. Find the absolute simplest version of it you can. And Arjun's answer? It's so simple, it's beautiful. You need a place to store two things, the shortcode and the long URL that it points to. That's it, a super basic database table. Think of it like a quick sketch on a napkin. This little drawing is the seed, the tiny starting point for the massive system we're about to build. It's the perfect first step. And then, bam, just like that, Maya introduces the real challenge. This is the moment everything pivots. We go from a simple little coding exercise to a full-blown, serious system design interview question. Because this question about scale, it changes everything. How in the world do you go from one user to a million? All right, so we've got our simple idea. Now it's time to stress test it. See, every basic design, and I mean every single one, has hidden traps, secret weaknesses just waiting to be found. A good engineer finds those traps before they become, well, catastrophic failures. So, let's go hunting. Okay, trap number one. This is a big one that Arjun totally overlooked in his napkin sketch. He said store a short code, right? But he never explained how we actually create that code. I mean, are we just making it up? Is it random? Is it sequential, like 1, 2, 3? The way you decide to do this has massive implications for the whole system. It's a critical decision. And that question leads us directly into trap number 2. What happens if two different people get the exact same shortcode? This is called a collision, and it's a disaster. You'd have two completely different long URLs pointing to the same short link. When that happens, your service is fundamentally broken. It just doesn't work. One of those links is guaranteed to fail. So, okay, we found the problems. How do we fix them? Well, for generating the code, a really slick approach is something called base62 encoding. All that really means is taking a unique number and converting it into a short string using a mix of big letters, small letters, and numbers. It's perfect for creating those short, clean URLs we all know. And for the collision problem? The solution, at least in theory, is simple. You just have to guarantee that the number you start with is always unique. And just like that, with these couple of fixes, our little napkin sketch is already starting to get more sophisticated. Okay, so we've patched up the big logical holes in our design. But now we face the scaling storm. This is where things get really intense. We're not talking about a few thousand links anymore. We're talking about building something on the scale of bit.ly or tinyurl, a service that has to handle billions of links and a nonstop flood of traffic from all over the world. So, of course, Maya comes in with the next huge question. Remember that single database from our napkin sketch? Yeah, that's not going to cut it anymore. Not even close. A single computer just can't store billions and billions of rows of data. It's physically impossible. So what do you do when you just run out of space? The answer is you have to go distributed. And the key technique here is called database sharding. It sounds complicated, but the idea is pretty straightforward. You take your one giant database and you chop it up into many smaller, faster, more manageable pieces called shards. Then you spread those shards across a whole bunch of different computers. By doing this, you can store a basically unlimited amount of data. But, look what just happened. This is a classic system design moment. In solving our storage problem, we've actually created a new, even trickier problem. Think about it. If we have all these separate databases, these shards, working independently, how do we stop two of them from accidentally generating the exact same unique ID at the exact same time? We are right back to our old enemy, the collision problem, but now it's way more complex because it's happening across this huge, distributed system. So let's look at how our architecture has evolved. We started at step 1 with that simple single database. Then, to handle all that data, we brought in step 2, database sharding, splitting everything up across multiple machines. And now, to solve that nasty distributed collision problem, we add the final piece of the core puzzle, step 3, a central unique ID generator. This is a dedicated service whose one and only job is to hand out unique numbers, one after the other. It guarantees that no two shards will ever get the same ID. Problem solved. And this is a huge turning point. When Maya says this, it's not just praise for finding a technical solution, it's about the shift in his entire mindset. Arjun isn't just fixing bugs anymore. He's designing a whole system that's resilient, that fits together properly. He's thinking about how all these different pieces are going to interact at a massive scale. He's thinking like an architect. But hold on, we're not done yet, not by a long shot, because having a system that works is one thing. Having a system that's production ready, that's world-class, that's something else entirely. It is time to tackle what Maya calls the hidden boss level of system design. These are the advanced topics that really separate a good interview answer from a truly great one. So what's on this boss level checklist? Well, here are the big 3. First, performance. How do you handle 100,000 requests every single second and make the redirection feel absolutely instantaneous to the user? Second, fault tolerance. Servers crash. It's a fact of life. What is your plan for when an entire data center just goes offline? And third, security. How are you going to stop spammers from using your service to create millions of links to spread malware and junk? And for every one of these tough challenges, there's a professional-grade solution. To solve performance, you use caching. This is basically just keeping your most popular links in super fast memory, so you don't even have to touch the database. You also use a content delivery network, a CDN, which puts your links on servers all around the globe, so they're physically closer to users. For fault tolerance, you use data replication. You make copies of everything, so if one whole data center goes down, a backup is ready to take over in an instant. And to fight abuse, use things like rate limiting, which stops one person from creating 1 million links a minute, and you maintain blacklists to block known bad URLs. And there you have it. Just take a second and look at how far we've come. We started with a tiny 2-column sketch on a napkin, and now we have a complete, robust, globally scalable system blueprint. This is the whole point of a system design interview. It's not about having the final answer memorized, it's about being able to show this exact journey of thought. So when it all comes down to it, the biggest takeaway here isn't some final diagram that you have to memorize. Please don't do that. The real lesson is that system design is a process. It's a journey. It's about constantly asking what if. It's about hunting for those hidden traps, and it's about making smart, intelligent trade-offs at every single step of the way. And so as you go into your own interviews, just remember Maya's final perfect piece of advice. The whole goal is to show your thought process. You have to explain the why behind every choice you make. So when it comes to your own answers, well, just don't shorten them too much.